Hello students, in this video we are going to talk about queues in data structure. Okay, see what is data structure? It is a way of organizing and storing the data, right? Then what is queue? Queue is an ordered collection of items where an element is inserted at one end called the rear end and an existing item is removed at the other end. We call it as front. Okay, so let us understand this concept with the real life scenario first of all. Okay, there is a ticket counter. Fine, it's a movie ticket counter, you can consider. Okay, this is, we call it as a ticket counter. Okay, and now there is no one is there in the queue. Okay, if there is a queue ticket counter, there is no one is enter or no one is there in that queue, right? So first you go and stand first there, and after that second, third, fourth, fifth, 5 persons are there. So obviously if you are the first, then you will get the ticket first, then you will go. After that second person, third person, fourth person, and then fifth person get the ticket, right? And suppose before you there are 5 persons. Okay, suppose you go late and then before you there are 5 persons in the queue, right? So you will have to stand at the 6th position, right? And you will get the ticket after the 5 persons, right? So here the simple funda is what? First in, first out, right? The simple funda for queue is first in, first out. Who enter or who stand first in the queue will serve as first, and then second, third, fourth person will serve the tickets, right? So in the queue this funda is known as FIFO, right? Queue is called as FIFO, first in, first out. Okay, in the queue only 2 operations are allowed, NQ and DQ. Okay, NQ means insertion of the element in the queue. DQ means deletion of the element in the queue. Insertion occurs at the back of the queue and deletion occurs at the front of the queue. These are the 2 operations in the queue. Types of queues. Queues can be of 4 types: simple queue, circular queue, priority queue, and DQ, double-ended queue. Simple queue. In simple queue, insertion occurs at the rear end of the list and the deletion occurs at the front end of the list. Okay, this is our queue, right? We call it as simple queue or linear queue. Okay, we have the items called A, B, C, D, E, right? The index are 1, 2, 3, 4, 5, right? So in the simple queue, the insertion occurs at the rear end, right? And the deletion occurs at the front, right? So here front is equal to 1, we indicates, and rear is equal to 5, right? Front is equal to index number 1 and rear is equal to index number 5. This is about simple queue. Circular queue. Why we go through the circular queue means we have a drawback in simple queue. That is, if we deleted a item A in the queue, then what is the front element here? The front item will be B, right? That is front is equal to 2, right? So the space of A become empty, but this space will not be used further. So this is the drawback of simple queue. So circular queue means a queue in which all nodes are treated as circular, such that last node follows the first node. That means this node is follows the first node which is already empty, right? So that becomes in a circular form. So we call it as circular queue. Priority queue. It means a priority queue is a queue that contains items that have some present priority, right? An element can be inserted or removed from any position depending upon some priority, okay? Not based on the index like circular queue and simple queue, okay? Circular queue and simple queue are based on the index number, insertion and deletion based on the index number, right? But in the priority queue, insertion and deletion is based on the priority of the queue. This is about priority queue. Next is Dequeue, that is double-ended queue. It is a queue in which insertion and deletion takes place at the both end. Say in the figure we can see that this is the front and this is the rear, right? So insertion and deletion can take place at the both end. That's why we call it as double-ended queue. Operations on queues. First is queue. Queue creates a new queue that is empty. Okay, if we want to create a queue with empty queue, we use queue operation. In queue, it adds a new item to the rear of the queue. First we create an empty queue using queue operation. Then if you want to insert an element in this empty queue, we use enqueue operation, okay? After adding some items into the queue, if we want to delete an item from that queue, we use dequeue operation. It removes the front item from the queue because deletion operation in the queue is performed at the front end, right? So it removes the front item from the queue. Then is empty. That means this operation tests whether the queue is empty or not. And then size. It returns the number of items in the queue. The size operation returns how many items are there in the queue. Next is memory representation of the queue using array. Queue is represented in memory using linear array, okay? Let us, queue is a array, two pointer variables called front and rear, right? We know that. The pointer variable front contains the location of the element to be removed or deleted, okay? The front element contains which element has to be removed or deleted, and the pointer variable rear contains location of the last element inserted, okay? And the condition front is equal to null indicates that queue is empty. Front is equal to null means the queue is empty, and the condition rear is equal to n minus 1 that indicates queue is full, okay? These are the about memory representation in the queue. See here we have the figure that indicates the memory representation. We have a queue, okay? The items are A, B, C, D. These are the 4 items we have in the queue. Then front item is A and the rear item is D, right? So what is the index of item A and item D? Front is equal to 1 and rear is equal to 4. And then we have rear is equal to rear plus 1. That means we add one item into the queue, that is E item. So what will become is the queue become front is equal to 1 and rear is equal to 5 because we add one element into the queue. And then item is equal to q of front, and front is equal to front plus 1. That means we delete one item from the queue. That becomes front is equal to 2 and rear is equal to 5, because a will be deleted here. This is about memory representation in the queue. Next, insertion operation in the queue, that is NQ. Consider an element queue with 5 elements. This is an empty queue, right? Here in empty queue, front is equal to -1 and rear is equal to -1. Okay. If you want to add one element in this empty queue, that is 8, then front and rear indicator are set to 0, because we want to insert an element into the queue, right? So the element 8 would be stored at the position pointed by the rear, right? So rear is equal to 0, front is equal to 0. That means q of rear, that is q of 0, is equal to 8. We inserted an element 8 in q of 0 in the rear position, okay? And then if we want to add one more element, that is 12 in the queue, then rear indicator would be incremented by 1. That means q of 0 is incremented by q of 1, right? That means rear is equal to 1 and front is equal to 0. Q of rear, that is q of 1, is equal to 12. We inserted 12 at q of 1. And repeat this procedure 3 more items to insert 4, 18 and 34 elements. Then we get the queue like rear is equal to 4 and front is equal to 0. Q now become Q is full. Algorithm for insertion. Here we have a NQ that contains Q, rear, front and item, okay? Where Q is the array with L elements, front is the pointer that contains the location of the element to be deleted, and the rear contains the location of the inserted element, okay? Item is the element to be inserted. Step 1, we have to check whether Q is full or not. For that, the condition will be if rear is equal to n minus 1. The condition is if rear is equal to n minus 1, then the queue is full, right? When the queue is full, we can't enter or we can't insert any element into that queue. So we have to exit the if statement, right? Other than that, if else, step 2 is we have to check whether the queue is empty, right? For that, the condition statement will be if front is equal to null, okay? If front is equal to null, write front is equal to 0 and rear is equal to 0. Else, rear is equal to rear plus 1, right? Incremented the rear pointer because we are going to insert an element into the queue. Step 3 will be Q of rear is equal to item. Then that means we have to copy the item into the rear position. This is the algorithm for insertion into the queue. Next, queue deletion operation. Okay, consider the queue with the 3 elements. Okay, this is a queue with 3 elements. Then front is equal to 0 and rear is equal to 2 here. Okay, suppose we want to delete the element 8. Okay, then the value of front will become incremented by 1. That means here front value will be 8. If we delete this 8, the front will be incremented by 1. That means front will become 1 and rear will become 2 here, right? Front is 1 and rear is 2, right? Suppose if we want to delete an element 12 again from the queue, then value of front will be incremented by 2. That means here front is equal to 1. If we delete this 12, then the rear is incremented by 1, that is rear is equal to 2 and front is equal to 2 again, right? Observe that Q has only one element when front is equal to rear. Okay, then the condition is true, then the Q has only one element. If you want to delete this item, then the Q becomes empty. Then front and rear pointers to -1, rear is equal to -1 and front is equal to -1, then Q becomes empty. This is about Q deletion method. And the algorithm for this deletion method becomes, we have Dequeue, which contains Q, rear, front and item, where Q is the array with n elements, front is the pointer that contains the location of the element to be deleted, and rear contains the location of the inserted element, and item the which element is to be deleted. Okay, step 1, we have to check whether the Q is empty. In deletion, we have to check first whether the Q is empty. If Q is empty, there is not necessity of any deletion in the Q. So that becomes Q is empty. We print Q is empty or Q is underflow, exit. Otherwise, step 2, we have to check item is equal to Q of front. We have to delete an item from the front element, that is Q of front. If front is equal to rear, if the condition is front is equal to rear, if the Q has only one element, then front is equal to null, rear is equal to null, else front is equal to front plus 1. If Q is not empty, we have to increment the front pointer to delete another item. This is about the deletion algorithm. Next is applications of Q. That is, first point is simulation, right? A queue is the combination of all entities in the system being served and those waiting for their turn. This we call it as simulation. Okay, various features of operating system. Okay, for example, input queue is a collection of process, right, in the storage that are waiting to be brought into memory to run the program. For that we use the queue in the operating system. Next is multi-programming platform systems, different types of scheduling algorithms and round-robin technique algorithms and printer server routines. Various application software is also based on queue data structure. These are the applications of queue.